Hello everyone, welcome to the session Serverless 2021 by AWS User Group Vizag in Mumbai. My name is Kumar. I'm the organizer of AWS User Group Vizag. We have Atul with who is our speaker, working as a serverless advocate at Antstack, as well as a co-organizer of AWS User Group Mumbai. Atul, go ahead and introduce yourself.
Yeah. Hi, Vani. Happy to be here, and thanks. Here, I'm going to present a webinar on Serverless 101. Myself, Atul Anil Kumar Kumbar, working as a serverless advocate at Anstack. Let's start with our session. This is the outline for our today's talk. What is serverless? The history of serverless, an overview of the serverless architecture, followed by benefits and limitations. Then we are going to see AWS services with respect to roles in perspective of serverless. Then we are going to understand the AWS serverless via AWS serverless lenses. Then some use cases, followed by the demo application at last. So what is the serverless? Serverless is a cloud computing execution model that automatically provisions the cloud computing resource required to run the application code on demand or in response to a specific event. It automatically scales to those resources up and down in response to increased or decreased demand. It automatically scales resources to the zero when the application stops running. Serverless offloads all management responsibilities for the backend cloud infrastructure and operations tasks such as provisioning, scheduling, scaling, patching, and more to the cloud provider. This gives the developer more time to develop and optimize their front-end application code and business logic. And with serverless, customers never pay for their idle capacity. Means they pay only for the resources required to run their applications and only when those applications are running. In short, serverless is a cloud-native development model that allows developers to build and run applications without having to manage the servers. So there are servers, means there are still servers in the serverless, but they are abstracted away from the application development. Let's have a quick overview of the history about the serverless. Here we analyze the evolution of computer technology that led to the serverless computing, which is going back to the 1960s. All the breakthroughs that indicate serverless computing would not have been possible a decade ago. Why? Because these technologies were not there. Particularly when we would have missed the enabling technologies such as the distinction between the infrastructure as a code, infrastructure as a service, rather, and a platform as the service. Also, fine-grained containerization like Dockers, and even the diverse set of various applications. So you can see few of those technologies as mentioned in the diagram. So broadly, we have distinguished them into 6 main dimensions of these critical breakthroughs that together led to the emergence of serverless. Yeah. So you can have in-depth reading. I have mentioned the DOI number of the IEEE paper regarding the history of serverless computing. Let's have the overview of the serverless architecture. Serverless differs from other cloud computing models in that the cloud provider is responsible for managing both the cloud infrastructure and the scaling for the applications. Serverless apps are deployed in containers that automatically launch on demand and when called. So this is the illustration of Pizza as a service by Paul Kerrison. And here to the right-hand side, you can see the two columns. Rightmost is the software as a service. Before that, we have function as a service. So for the function as a service, let's take an example of a scenario of you go to a pizzeria where some friends and you order and then eat the pizza, which is made by the restaurant. And you order the drinks from the bar, and they are made for you. And we can equate it with the AWS Lambda. We use the service from the AWS Lambda for our computation in the serverless. Whereas in case of software as a service, let's consider a scenario where you go to someone's house for a party and they provide the pizza and invite you to invite others for the conversation with you. But here again, the conversation with the guest is still your own responsibility. So we can relate this with the example of Gmail service. Yeah. So this is the cloud computing service model. Here we are going to see what is the cloud provider's role in the serverless computing. Under a serverless model, a cloud provider runs a physical server and dynamically allocates their resources on behalf of users who can deploy code straight into the production. The serverless computing offerings typically fall into two groups, a backend as a service and function as a service. So backend as a service gives the developers access to a variety of third-party services and applications. For instance, a cloud provider may provide authentication service, extra encryption, cloud accessible database, NoSQL database, for example, DynamoDB, and high fidelity uses data. With backend as a service, serverless functions are usually called through the application programming interface, means APIs. And more commonly, we have when developers refers to the serverless, they are talking about the function as a service model, under which developers still has to write custom server-side logics, but it's running in the containers fully managed by the cloud service providers. Yeah. So long story in short, these serverless functions are currently we have we have them as a functions, but the story is we gone it from monolithics to microservices and now to the functions. So as we know, the microservices have the property of they are small grain services, though their function is specific and their capabilities are well defined. And it's executed by the architecture domains like event handler, serverless backends, and data processing. So the main principles of function as a service is it has the complete abstraction of the servers away from the developers. The billing is based on the consumption of the executions, not the servers that not on the server instance sizes, as we do in the EC2 instances. Services that are event driven and instantly we can scale it. Benefits of the serverless computing. To the left-hand side, you can see the generalized benefits of the serverless computing. So I'm going to, we're going to see in brief the right-hand side, means with respect to AWS, no patching of the servers, means AWS patches all the underlying servers of its serverless components. No scaling required. AWS auto-scales its serverless components too. Out-of-box monitoring, AWS Lambda allocations, durations, errors are monitored by default. No logging setup required. Standard output automatically is piped into AWS logging capability. So these we are going to see in our demo application in some time. Minimum tracing required. AWS Lambda environments are already configured for tracing. No web server required. Cloud from AWS front servers are static assets which use hyper effectively performance. Then the distributed corn out of box, which uses AWS CloudWatch events to trigger and containerize the task or Lambda easily. And we can use the SQS and SQS FIFO, which allows us to create queues for our event-based applications for scaling up the queues. So this is also used for decoupling our architecture that we are going to see in the one of the use case architecture diagram. No separate secret management tools are required. AWS Lambda can read secrets from AWS Secret Manager and AWS SSM. No complex network permissions required. IAM allows a far more granularity, security, and permits for your functions and many more. So we are going to see what are the limitations for serverless computing. Before that, we are going to see how whether the serverless computing fits for our use case or not. So it fits well for a net new application where we have the value for scaling and it is a service oriented. It is not fit for a legacy and where we are not having a value for scaling and the application is traditional. So even though you can go for the serverless, but it will cost you more. And with respect to the limitations, it is specific to public cloud. It is not portable for other platforms. Still, we need some open standards for it. The security, governance, and services are not portable either. So there is a limitation for functions, means how far it can run. As of now, Lambda can run for 15 minutes. Previously, it was 5 minutes. The cold starts. So these are the listing of AWS services with respect to serverless. And from the perspective of the various roles that one might be interested. So there are some common AWS services, the services which are mostly used in front end, back end, DevOps, and data engineering. So those who are about to start about the serverless, they are going to learn or explore more. So you can use this. Also, there is a YouTube link mentioned at the bottom. You can refer it for the detailed information on the role-wise AWS services. Yeah. Now we are going to have a look on AWS serverless services with respect to serverless lenses. Serverless lenses is the definition, is a set of definitions or the guidelines which are best practices designed by AWS from getting the feedback from their users for their various workloads over the year. So if we follow these standard set of guidelines, then our the pillars of a well architected structure or the framework. Here we will have a quick overview of the 7 areas and its services which we should consider while building our workload, namely compute layer, data layer, messaging and streaming layer, user management and identity layer, the edge layer, and the streaming and monitoring and the deployment approaches. The compute layer. Here we have the services like AWS Lambda, the API gateway, the step functions. The compute layer of your workload manages the requests for the external systems, controlling access and ensuring the requests which are appropriately authorized. It contains the runtime environment that our business logic will be deployed and executed by. When we consider the Lambda, it lets you run the stateless serverless applications on managed platform that supports the microservices architectures, deployments, and management of the execution at the function layer. Whereas the API gateway, you can run a fully managed REST API that integrates with the Lambda to execute your business logic, and it includes the traffic management, also authorization and access control, monitoring and API versioning. So that you can deploy your application versions. AWS step functions. It orchestrates the serverless workflows, including the coordination of the states and the functions chaining, as well as the combination of long-running executions, which are not supported by the Lambda execution limit, which is a 15 minute that we have seen earlier. Yeah. As we know that the serverless computing is mostly event driven, and the main compute engine of AWS is the Lambda. And Lambda, this is the pictorial illustration of the various event sources that Lambda supports. It gets triggered for the computation. So we have the S3, the NoSQL DynamoDB, then API gateway. We have the voice device, Amazon Alexa, the CloudFront, Kinesis for live data streaming. Yeah. Next, we have the data layer, in which our workload manages the persistent data storage from within the system. It provides a secure mechanism to store the states to your business logic, which, as per the business logic's need. It provides the mechanism to trigger the events in response to the data changes. In previous slide, we have seen the Lambda, triggering of Lambda with respect to changes in the DynamoDB or the S3. Yeah. So Amazon DynamoDB, which helps us to build serverless applications by providing a managed NoSQL database for persistent storage. When combined with DynamoDB streams, you can respond in the near real-time changes in the DynamoDB table by invoking the Lambda functions. Then we have the simple storage services, name acronym is S3. You can build the serverless web applications and websites by providing highly available key value store from which the static assets can be served using the CND, means content delivery network, CDN. Sorry. Also, we have the service named as Amazon Open Search Service, which is a successor of Elasticsearch, which makes easy to deploy and secure, operate, and scale the Elasticsearch for the log analytics. We have the AWS AppSync, which manages the GraphQL service with real-time and offline capabilities. Messaging and the streaming layer. Here we have the SNS, means a simple notification service, the Kinesis, and the Kinesis Firehouse. Here your workload manages the communication between the components, and the streaming layers manages the real-time analysis and the processing of the streaming data. SNS provides a fully managed messaging service for pub/sub patterns using asynchronous events notification and mobile push notifications for microservices, distributed services, and serverless applications. The Kinesis, which makes easy to collect, process, and analyze the real-time streaming data. Also, we have the Kinesis data analytics. Yeah. Next, we have the user management and identity layer. Here, the Amazon Cognito and the Cognito federated identities. Both provide a workload, the capability to identify, authenticate, and authorize both the external and internal customers of your workload interface. With Cognito, you can easily add the user sign up and sign in and data synchronization to the serverless applications. It provides the built-in sign screens and federation with Facebook, Google, Amazon, and SAML, means security assertion markup language. The Cognito federated identities lets you to securely provide scoped access to AWS resources that are part of your serverless architecture. Then we have the edge layer. The edge layer of our workload manages the presentation layer and the connectivity to the external customers. It provides the efficient delivery method to the external customers residing in the distinct geographical locations. Here we use the AWS Amazon CloudFront, which provides a CDN that securely delivers the web application content and the data with the low latency and high transfer speed. Then we have the system monitoring and the deployment layer. Here we have the services like of our workload manages the system visibility through the metrics and creates the contextual awareness of how it operates, behaves over the time. Here we get the data or metrics for pivoting our application or tuning our application. The deployment layer defines how your workload changes are promoted through the release management process. With the CloudWatch, you can access the system metrics on all the AWS services that we use, and we can consolidate the system and the application level logs and create the business key performance indicators, means the KPIs. So we are going to see the CloudWatch log in our demo application. Next, we have the X-ray, which lets you to analyze and debug the serverless applications by providing the distributed tracing and service maps to easily identify the performance bottlenecks by it visualizes the request end to end. Yeah. Let's move on to the use cases. Given its unique combination of attributes and the benefits, our serverless architecture is well suited for the use cases like microservices, the backend, and the data event streaming process. When we consider the microservices, the most common use case of the serverless today is supporting microservices architecture, and the microservices model is focused on creating small services that do the single job and communicate with one another using the APIs. API backends or the mobile backends, any application or the function in the serverless platform can be turned into a HTTP endpoint ready to be consumed by the web clients, and we can take it forward from those HTTP endpoints. Then we have the data processing. Serverless is the well suited to work with structured text, audio, and video data, and around the tasks such as data enrichment, transformation, validation, then cleansing, etc. We have some common applications or the web applications, a wide range of applications, for example, CRMs, customer relationship management, analytics, and business intelligence, finance, and others. So this is the reference architecture for web application. So we are going to have a walkthrough from this, along with the sequence. First, the customer of the web application might be geographically concentrated or distributed worldwide. Leveraging the Amazon CloudFront not only provides a better performance experience for these consumers through caching and also by optimal origin routing, but also it limits the redundant calls to your backend. Then we have the S3, which hosts the web application static assets, and it is securely served through the CloudFront. At the third point, we have the Amazon Cognito, which provides the user pool management and identity provider feature for the web application. At the fourth step, we have various scenarios such as a static content which is served from the AWS S3 is downloaded by the customer, and the dynamic content needs to be sent to the to or received by our application. And for example, when the user submits a data through a form, the API gateway serves as a secure endpoint on behalf of the application and makes these calls and returns the responses displayed through the our web application. The fifth point is AWS Lambda. So the Lambda function creates and read, means CRUD operations, create, read, update, and delete for our DynamoDB. And the sixth is Amazon DynamoDB. You can provide the backend NoSQL data store, which elastically scales with the traffic of our web application. Yeah. So here we have one. So I have taken this from the use case of the Deloitte. So they have compared two applications. Where one is based on transportation organization, and one is on the healthcare domain. So they developed on both EC2 and the Lambda, and they have compared the cost at various layers. Means the 7 layers we have seen. So at various layers or the stages of the application development, how much it costs. So for the infrastructure, somewhere the serverless costs more, a bit more, and but at all other fronts it costs less. So here we have to find out of what size uh, the lambda should we use and for how many minutes it should run. So you can tune our lambda requirement, or you can get the optimal lambda means memory requirement. We have one third party tool for that. So you can visit our company's Anstrax YouTube channel. We have a video on that where you can find out the optimal uh, lambda memory required for our workload. So overall, we we have a good result for the serverless. Mean it saves a lot when compared to the EC2. Yeah. Now we are going to see a demo, which is an application. It takes input of photos as a JPG, and it extracts the facial boundaries or the coordinates, and it blurs that particular facial part. Okay. So its detailed implementation and demo is again available on our YouTube channel, and you can refer. The link is provided here. Let's start with the demo. Sorry, I will explain the architecture. Here we have the source bucket. When the user uploads an image to the source bucket, the information about that particular image is given into the SQ. Means what is the name, what is the name of that object, means the file, and the name of the S3 bucket. Then it triggers the lambda, which extracts the parameters, whether there is a human face in that, and it extracts the parameters, and it is sent for the uh, further operation, means masking the particular, means blurring the particular coordinates, and the final output image is stored in the destination bucket. So here I have downloaded a few objects, images. We'll add those images. Okay. Yeah. So just a moment. Okay. Sorry for the miss. The button was hidden there. Yeah. So we have uploaded our image. It is successful. Yeah. So this is our destination bucket. So our images were called sent to SQS, and SQS called the Amazon recognition from Lambda. Then Lambda in return called the service of AWS named as recognition, which extracts the special features, and it is sent back for the blurring to the Lambda, and it's stored in the destination bucket. Means here. So we will download. We'll download this. So you can see here in the F, the original one. So these are the facial extraction feature, which is used in real time, and everything is decoupled. We have means you can upload n number of files at a time. So those will be stored in the queue and called according to the logic, means first in first out, and it will be served. So we don't have to worry about the flow of upload, or rather the traffic flow. Yeah. So the D, even the face is slightly tilted, it is still recognizes, and it's masks the face. So such powerful analytical extraction tools are available on the AWS. Yeah. Now we are going to see the CloudWatch, where we get the details about various AWS services logs and its metrics. In the CloudWatch log group, we can see, yeah, we can update it here. Yeah, for this service, we can check various log executions. Yeah, we have the latest one, 730. For each object, means the photo uploaded, we will have a different set of executions, or the flow rather. So I have explained in detail in the link provided in the video on our channel, that various sections from this code and the log. Here in the body, you get the this is the name of our image, name of our bucket is passed. Then we have yeah, here we get the actual extraction of the means, or the location of the each face from the particular image. For the each object, you can get these coordinates details, and these coordinate details are passed to the next lambda for the masking, and it is blurred, and the final output is stored in the lambda. Yeah, this is how the lambda source code for that. Yes, we are done with our today's content. Yeah, if you have any questions, please.
Thank you, Artul. It's a very helpful session. Uh, let's people who are joined the call, please post your questions in the chat so that we can go ahead and read it out.
If you have any question regarding AWS, particularly with respect to serverless or AWS certification, you can reach me out uh, at atul at @anstack.io is my email, or you can reach me out via my LinkedIn. Any questions in the chat box?
No. Okay, one quick question. Can we use serverless for machine learning works? So,
Yeah,
what is
we
your
yes, definitely we can use serverless for machine learning, and we have analytical tools from the AWS. Rather, we have a separate certification from AWS uh, machine learning specialty. Yeah,
okay?
there are a lot of services and scope for machine learning and serverless. Yeah.
Okay. One more question. How step functions helps in increasing the productivity, and when should we use serverless? Any specific use cases in that?
Yeah. With respect to step functions, as we have seen that particularly lambda or the functions in the sense when Azure function or GCP function, or in AWS we call it as a lambda. They have limitations of execution time is maximum is 15 minutes. When we need access time for our business logic or there is a human intervention, then we go for the step functions.
Okay.
So which maximum period is 1 year.
Okay. Can you explain scenarios where we should use streaming activity and use Lambda as a destination to process the applications?
For streaming, we use AWS Kinesis or Firehouse for storing the live streaming, or the AWS Kinesis data analytics to extract the features. For example, any sport uh, live streaming, we can predict the future action or the moves.
When should we use actual serverless to actual servers? So, any specific scenarios that avoids using
Yeah. When we should we use serverless?
when compared to actual servers? Any
Yeah, yeah.
specific scenarios is what?
Yeah, as So when there is a need of abrupt or a random scaling, uh, and the scaling, we don't know how the application will get the traffic. At that time, we can go for the serverless because it scales automatically. There is no need to manage the scaling requirement of the application by the developers. Or else when, for example, we are going to develop a web application from scratch, is new one, we are not porting any legacy application. At that time, you can go for such means serverless approach. Yeah. Also, we can take an example of mobile as a backend where we can see, yeah, for the mobile as a backend, we have the users which need the most of the responses in quick and real time. In that case, we can use the AWS CDN or edge computing services at that time. Yeah. Yep. Any questions?
Uh, that's all. Atul. So no more questions from the chat. Thank you very much, everyone, for joining the session, and thank you, Atul, for providing your valuable information to our users.
Thanks, Pani,
Thank you.
for having me. Thank you.